Hey gang, today we're going to talk about using right triangles to find the slope of a line. So we're not going to be doing very much different. We're just going to be looking at the points in the triangles A, B, C, and D, E, F to find our rises and our runs, which compute to our slope. So let's remind ourselves of a few things real quick. So first we need to remember that slope is measured as rise over run, and that means that they are y values over our x values, or our change in y over our change in x. So we're going to be looking at the rate at which y changes compared to how x changes, and we can make right triangles out of those changes. So let's look at the first triangle ABC. Triangles are labeled by the points, and you see that the points have been made on the graph for you, and they're labeled A, B, and C. And so the first thing they ask us to look at is they ask us to find the run. And so our run is going to be from C to B. So we're going to travel from point C to point B. So our run is C to B here. So if we go to point C and we count over how far it is from point C to point B, it's going to be 1, 2 spaces, so 2. And our run, excuse me, that was our run. Our rise is going to be from B to A, or A to B, however you like to think about it. But from B to A is going to be 1, 2, 3 spaces. So now we have our run and our rise, and our slope. We have to remember that slope now is going to be our rise over our run. So we can mark that slope is rise over run. And our rise value is 3, and our run value is 2. So our slope is going to be 3 over 2. And that's all you do. You just compare the sides of the triangles to find the slope. And so this distance right here would be 3/2. Let's look at triangle DEF, and we'll use some different colors here. Let's start with blue. So the run for DEF, well, we have to look at DEF, and our run is going to be the x values from F to E, so our distance from F to point E. Okay, so let's go to our graph in this first triangle right here. We're going to start at this red dot, and we're going to go over 1, 2, 3, 4, 5, 6. So 6 spaces. Our rise, we'll change colors again. Our rise is going to be the y values, so from E up to D. From E up to D. And we're going to go from E, so we'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So our rise is 9, and our run is 6. And we know that we can find slope by computing the rise over the run and so our new slope is going to be 9 over 6, and 9 over 6 reduces to 3 over 2, so our slope is going to be 3 over 2. Both of our slopes are 3 over 2. So now we go look at part 3. Are the two slopes computed above equal? Well, did we find 3 over 2 and 3 over 2? Yes, we did. So now we have to decide if it's because the triangles are similar or if the triangles are congruent. So we need to just remember that congruent means the same exact shape. Same dimensions and everything. Okay, similar means the same shape but proportional proportional sides or proportional dimensions. So we're going to have same shape and it's proportional. So, do we have the same exact shape or do we have same shapes that are proportional? Well, 3 and 2, 3 over 2 is equal to 3 over 2 here. So we can claim that they are similar. So similar triangles create proportional relationships. And then if we have reduced slopes, that's going to be yes, that they are similar and that they are equal. So the slopes are the same because the triangles are similar. And there may be a case where they are congruent, and that would be where our slope is never reduced, really. So these are equal because they are similar.